Do you have a microscope and you need an illuminator for it? You can buy them. They're pretty expensive, but there's another option. If you have some old LED bulbs that are no good anymore, what you can do is take them and carefully break off the top. And if you look on the top, there's 2 rows of LEDs on this one. And it's fairly easy. You've got a couple screws here. You can unscrew them, and then this piece can be removed. And I did that on this one. As you can see here, you've got your row of LEDs, and in the center you've got 2 connections, a positive and a negative. And you can carefully solder these. And if you do break off the pads here, if you just file back, you can see the traces underneath here. And what I did, the pads came off, the pads were here. I just abraded down to the foil, down to the copper, and then I just soldered a set of leads there. And once you do that, you can test the LEDs. I have an LED tester here. I'm going to plug it in. You can see the voltage is ramping up on this thing. It says 157 volts. Actually, can go higher than that. I am going to angle this away from the camera a little bit because this is going to be really bright. And there's 2 leads here, and if I connect the negative and the positive, you can see they become quite bright. And here the voltage reading on the device here, you look at it. These are running at 64.6 volts. So if you apply 64 volts here, or you can vary it if you want a variable intensity, you will get the output. And I found when I take these bulbs apart, when they go bad, the LEDs are usually good. It's the electronics inside. Unfortunately, they use some fairly cheap components. Capacitors, electrolytics in here, these generate a lot of heat, so the capacitors are a weak point. So what I did here, and I'll zoom in a little bit, I took one of these LED arrays here and I mounted it on an old heat sink. This is out of some piece of electronics, I can't remember what it was, but anyway, I put leads on it. Here's a switch mode power supply out of some old piece of equipment, 54 volts at 1.6 amps. Plug it in. So what I did, on this end I have just a regular barrel connector, and turn this away, plug them in, and there you go. Quite a bit of light coming out of that. In fact, if you want, you can measure it here. Here I've got a light meter here. Here's about 2,000 lux coming out of that thing. That's at this distance, and the distance to the microscope will only be between the optics is going to be short. There'll be some attenuation through the lenses and prisms, etc. But anyway, that's quite a bit of light generated by these things. You can also use the domes as diffusers if you want to use them. Anyway, I'm going to take this and I'm going to hook it up at the open source where you put a lamp for the microscope, and then we're going to see if we get any luck with this thing as an illuminator. So I'll do that next. I plugged the LED array into the power supply, and now I'm going to place it in the opening in the back of the microscope, I think. There we go. On the stage of the microscope, I placed a DVD that I have torn off the label, so in other words, you can look through it here. It's got the lines on it. You can see where I ripped the silvering off. Anyway, I'm going to place that on the microscope here. Okay, on the stage of the microscope, I've got a DVD, and here on the screen you can see the tracks. As I move this here, you'll be able to see it. You can see the individual tracks on the DVD. And of course the light from the illuminators coming up through the optics up through the bottom here. You can also use these if you wanted to. In fact, what I'm going to do is take two of these to view objects on the top of the stage. I'm going to illuminate from each side so I don't have shadows, so I can actually observe things from above here. Put a drop of water on a slide here, and I'm using a camera here. Camera comes down through the tube here. You got the eyepieces, but the camera can also view the whatever's on the stage. As I move this, you got to see what pond water looks like. We filter the water. This looks pretty good. This little worm here is not a worm. It's just I got to clean the lenses on here. I haven't used this in a while. I can adjust the focus here. It's fun to put like pond water on here and watch things moving around. Realize you'll be drinking that stuff. And you can move the illuminator here. It's quite warm. You really need to put a heatsink on that. I really like these LED testers here. I use this to test backlights on LED televisions and monitors, but you can also use it for even testing a single LED. Now, you see it says 316 volts, and they're not lying. Watch the meter. 312. So it's putting out some pretty high voltage, and you might say, well, won't this blow up an LED? 300 volts on a little 2-volt LED? Well, the secret is this thing is current limited. It's gonna, watch here when I connect it to the LED. Whoops. Never say oops. Watch this when I connect it to the LED. No, I hooked it backwards, which is the reverse voltage, you don't want to do that on an LED, but to show you, this thing still works. And if you look at the little meter here with the blue, it'll tell you the voltage that is across the LED. There's 2 volts, 1.9, 2 volts, which is normal. Most of these LEDs are a couple volts at 10 or 15 milliamps, 20 milliamps at the most maybe. So now it's going to ramp back up to 300 volts, and I can actually do it now to this array. You don't want to touch these leads. It won't kill you, but it'll give you a little bite. And there you can see that's measuring 64.7 volts. And it's good to put the caps on these when you're not using them. These are really handy if you work on TVs or monitors, by the way. So anyway, this is handy to have. So if you have some old LED bulbs here that go bad, no good. Oh, you can use these as diffusers too. But anyway, 2 screws on this one. Some of them have 1. 2 screws unsolder, and you pull this off. You pry them off here. These come off. You can pry them off quite easily. If you look on the back, this is just aluminum, and they'll pry off. And solder a couple leads on there, and you've got a nice light source. And I've noticed some of these are rated at, like this one's rated at 64 volts, I think it was. The other one was at 50 some. So it depends on the number of LEDs, what voltage it is. So that'll vary. Let's see if these are any good. Looks like this one is no good. Okay. Anyway, can't win them all. Looks like this one's bad. You can see the pads on here that go to the LEDs. Oh, look at, we got one burnt out there. So let's try this. Let's try an individual LED and see if we can do that here. Oops. The wrong polarity. There we go. Here's a good one. See, you can go around. So evidently this one blew up here. So that's why this one went bad. Well, anyway, I'll finish this video now. So hope this was helpful. If you need to make a light source, you can use them for microscopes or any other thing you want to use. These are pretty nice. Like I say, just mount this on a heat sink, because this gets really hot. You need to pull the heat off of here. I use some heat sink compound. Use an old heat sink from a computer or power supply, something like that. So you can see the heat sink on this thing here. They got heat sink grease. So that's it for this one. Thank you for watching, and we'll see you in the next one. Bye for now.